Alright, so it's time to finish up logs. You'll notice that in your textbook there is nothing to do with natural logs. Alright, in fact it kind of surprised us many years back because it's in the course but it's not in any of our original assignments. So the good news is it's nothing different than anything else. So far we've seen all kinds of different bases. We've seen base 2, base 4, base 7, base 10. We can do any base. What's nice is base 10. These are calculator questions. All right. The natural log is a little different. Okay, the natural log has a base that isn't one of these numbers. All right, so let's get into that a little bit. What is the natural log? Okay, so when we do questions like this, pretty straightforward. You're just going to type these into a calculator. Okay, so those are just straight type it in a calculator. Nothing too complicated there. If you remember questions like this, how do we solve this? Well, you should remember that this is one of the three types of log equations. It's one with log on one side. When there's log on one side, you change to exponential form. So knowing there is a base 10 here, I can write this as 10 to the power of 5.26 equals x. So x is 10 to the power of 5.26. So you get a number like that. Same with this one. This is going to be 10 to the power of 0.35 equals x. So 10 to the power of 0.35 is 2.239. Okay, so those are straight calculator questions. And these all have to do with base 10. So now what does that have to do with the natural log? Well, the natural log is the log of a number with base e. All right, base e. Well, what is base e? This is something you haven't seen before. Okay, well, we can't really tell you what the number comes from because you need calculus first. So this is kind of like going backwards a little bit. But if you understood calculus, you would learn something about limits. So e comes from when n approaches infinity in this equation. Okay, and so as n gets bigger here, we get closer and closer to the actual number. So the value of e is approximately that, although the number is kind of like pi in that it has decimals that continue on forever without anything repeating. Okay, so in your head, when you think e, you're thinking to yourself, this is about 2.7. Okay, that's good enough for what you need to know. But your calculator is programmed for e. So e is actually a value that you can use your calculator for. So if you see log base e, you actually won't see that. You'll see this, which is the natural log. This is actually a button on your calculator, so go and find that. So you can take the natural log of 5.36 and you get 1.679. Okay, so natural log, for all you need to know right now, is that it is a base of e. So when you see ln, you're thinking that means log base e. So you're knowing also that this is going to be a calculator question. Okay, and then here's one that you need to know without the calculator. I'm going to say this is going to be your best friend when you're solving equations with natural log. Alright, so think about this. The natural log of e. This means e to what power is e? Well, this equals 1. Okay, that's going to show up a lot. You'll see very shortly. Okay, so if we want to solve this, same thing. If you see log on one side of the equation, you're going to change to exponential form. So you have e to the power 4.1 is x. That is also a button on your calculator, the e button. Alright, so you're going to go e to the power of 4.1 and you get 60.340. And then if we want to do this one, e to the power of 0.89, So x is 2.435. Okay. Now the good news is that the natural log works exactly like all of the other logs. It follows the same rule. Okay, so if I'm thinking about how am I going to graph this, well, in your head, you know that e is 2.7, so this is about 2.7 to the power of x. This should be very similar to y equals 2 to the x, or y equals 3 to the x. Okay, so if we're thinking about y equals e to the x, we just know that it's in the middle of those two. So let's quickly try those. Okay, so in our head, let's quickly think about this. This graph, if we said this was y equals 2 to the x, you'd know it would cross at 1, and then you would have a point where x would be 1, y would be 2. Okay, if you also drew that the value of y equals 3 to the x, again it's going to go through 1, but this point would be 1, 3. So where is y equals e to the x? It's going to go right about in the middle of that. Y equals e to the x, you're going to get a value of 1. And what's this point here? Well, I want you to write that's 1 and then e. Rather than round it off, leave it as a value of e. Okay, so we have horizontal asymptote. There's our graph. Okay, so let's do a couple of quick transformations. Let's start by graphing y equals e to the x. So that's going to be like this. And let's put 2 points here. I know that one's 1, and I know this one's 1e. Okay, now if I want to do this, what does that negative do? That negative is going to be a vertical reflection. It's going to take the y values and turn them upside down. So you're going to end up going down here. Okay, but then we're also going to add 1. So let's do this in one step. If I take positive 1 and go to negative 1 and then add 1, it's going to end up right here. If I do 1 comma e and I will make it 1 comma negative e, but then I add 1, all right, it's going to be 1 negative e plus 1. Now, in your head, you know that's about negative 1.7, but you don't have to write that. Okay, and where does the asymptote go? Well, if we flip it at 0, it stays at 0, and then up 1. So it looks something like this. This graph would be like that. Okay? And the nice thing is x and y intercepts are already figured out for that one. Let's try another one. Y equals e to the x. Okay, you know what that one looks like. Alright, now what is this going to do? That's a horizontal reflection, so it's going to end up like this. And then it's going to go down 3. Okay, so let's take this point, the y-intercept. If I do a horizontal reflection, it stays there. But if I go down 3, it ends up at negative 2. Okay, and if I take this one and I do a horizontal reflection, it's going to be at 1 negative e. Sorry, negative 1e, and then it's going to go down 3. Now think about that. If you're going to go down 3 from e, it's going to turn negative. Okay, so this is going to be negative 1, and it's going to be e take away 3. And in your head, what's e take away 3? Well, 2.7 take away 3, that's about negative decimal 3. Okay, and one last thing we need to do is we need to take a look at that horizontal asymptote. If it goes down 3, it's going to be here at y equals negative 3. Okay, oops, that didn't hit. So the only problem with this is we suddenly have an x-intercept we need to figure out. Okay, what do we do with the x-intercept? Y is 0. So you're going to have 0 is e to the negative x minus 3. Okay, how do you solve that? Well, let's go over here and take a little more room. So e to the negative x minus 3. So let's add 3 to both sides. Okay, now how do we solve this equation? Well, this is one of the 3 types. There's no logs, but these bases cannot be made the same. So we're going to take the log of both sides. Right? This is that type of equation. Now, the only thing is, because I see e, I'm going to take the natural log of both sides. Okay? This allows me to put the x in the front. So I'm going to have negative x. And do you recognize this? Well, that equals 1. So now you have x is negative the natural log of 3. Okay, so let's figure that out. So then x is going to be negative 1.099. Now you can, if you want, you can write that just as negative the natural log of 3. Okay? So let's write x-intercept over there. Okay, one more. Y equals e to the x. So that's this one. Alright, and then what are we going to do? There will be a vertical stretch of 3 and left 1. So let's do the asymptote first. If we do a vertical stretch, if I multiply that by 3, it stays the same. If I go left 1, it is still here. Okay, if I take the y-intercept and I multiply it by 3, it becomes 3 and then left 1. So this point is going to be negative 1, 3. And if I take this one and multiply it by 3, it becomes 3e. And if I move left 1, it will become that point will just be 3e. Okay, so my graph will look something like that. Stretched and back 1. Alright, the good news is with the natural log, same rules, so let's quickly remind ourselves, what does y equals log base 2 of x equal? And what is log base 3 of x? Well, they're going to be like this. Which one's which? Which one turns sharper? Well, this is going to be log 2, this is going to be log base 3. What are the points? Okay, well, if you remember, how do we do this? We're going to pick y values. If we make y value 1, okay, if we make the y value 1, you're going to get 2, 1, and 3, 1. If you're not quite sure how to do that, let's look at this one. Okay, if we say y is 0, then you'd have 0 equals log base 3 of x. So changing to exponential form, 3 to the power 0 is x. So x is 1 when y is 0. That's the x-intercept. Okay, if we take y as 1, then you get 3 to the power 1 is x. So when y is 1, x is 3. That's where this point comes from. Okay, hope that makes sense. Now, where is this? Well, in your head, you could be thinking this is log base e of x. It's the same thing. E is between 2 and 3. So this graph is going to look something like this. And that point right there is going to be the point E1. Okay, hopefully that makes sense. Let's try another one. So let's graph this. I know that the x-intercept is 1. And I know there is going to be a point here when I pick y is 1 that x will be e. Okay, and I'm going to do a transformation. We're going to go y is negative ln x, so this is going to be a vertical flip, and then up 1. So let's flip this vertically and up 1. The asymptote will stay the same. If I flip the x-intercept, it's going to stay the same, but up 1. Okay, so that's going to be the point 1, 1. And then if I, then if I take this one and flip it, it's going to become e negative 1, but then up 1, it will become e 0. And so this graph would look something like that. Okay. Let's do y equals ln x. That's like this. And this one's an easy one. All we're going to do is go left 2. So first the asymptote, then the x-intercept, and now this is a little weird. Where does e go if I want to move it left 2? Well, it's going to turn out to be e take away 2, which is still positive. Okay, comma 1. And the only problem here is we now have a y-intercept that we don't know. So let's make x be 0. Y equals the natural log of 0 plus 2. So y equals the natural log of 2. Okay, and if we want to do that, we'll go... This is 0.693. So this point right here is 0.693. Okay. Try one more. Do the natural log of x. And then we're going to do... Alright, we're going to stretch it vertically by 2 and we're going to flip it horizontally. So, if we stretch the asymptote and then flip it horizontally, it does not change. If I stretch the y-intercept by 2, it doesn't change. Flip it horizontally, it becomes negative 1. If I take this point right here, it's going to, if I multiply it by 2, it's going to become E2, but then it's going to flip, so it's going to go to negative E2. Okay? So there's our graph. So that's good practice. They just look like the log graphs and the exponential graphs. Okay, we'll take a break there. I will give you the rest of it in the next lesson.